Yeah, so get your Hot Pockets in, get your pizza in today. It's pizza day, so pretty excited. All right, let's make this happen. Today, we're going to go through some quick announcements so that you know what's up for today, and then we'll jump into our notes and our assignment. So first announcement is that the Los Angeles Urban League has some math support, which is pretty cool. I'll tell you why it's cool here. What is the Urban League, though, just to start? It's a local organization that seeks to empower Black and Brown communities, and they offer a ton of cool programs like a high school mentorship program and college tours, and they also offer math tutoring. Woohoo! Here's what's cool about this math tutoring, right? You can do any level of math, so Algebra 2, that's great. It's on Tuesdays, Wednesdays, and Thursdays after school from 3:30 to 5. And here's the best part. In addition to getting math help, they actually pay you for going. So they will give you a gift card, right? It's a Walmart gift card. Walmart sells basically everything on the internet. If you go, they will give you $10 every week. So if you go every week, they'll give you $10 every week. That's pretty cool. Then you can get your math homework done. You can also get a gift card. That's pretty awesome. So I'm gonna drop a link here. If you are interested, this is the link for tutoring. Which I totally spelled wrong. Here we go. Tutoring. I can do this. Yes. The link for tutoring is there. You're going to fill out that form, and then BusyZ will connect you with the organization. If you have any other questions, you can talk to James Breedlove. But yeah, getting paid to do your math, let's make that happen, right? Like this is just like free money waiting to happen, and you got to do your math homework anyway. So you don't have to tutor I just want to make clear, you don't have to tutor other people. Like they're going to help you and they're going to pay you. I don't know how that happens, but I love it. So even if you're just doing your math homework, might be cool to check out. So there's the link one more time. I will copy it again. Here is your link. And I am super pumped to have y'all sign up if you want. Also, here's the attendance link, just in case you missed it. Cool. So shout out to Los Angeles Urban League, really making some stuff happen with the math support. Okay, we have something I want you to check out. So I'm going to show you a problem like what we're going to do today. And I want you to see if you can figure out the pattern before we even do the notes. Okay, I want you to see if you can figure it out. So here is the problem. Right? Here's your guiding questions. What do you notice? What are some things that you notice? What do you wonder? Right? So if you have a thought or a question or something that you're wondering about, but this is the problem here. So this is the problem, 4 square root 14 divided by 8 square root 2. Right? So this is the problem. And then it works through this way, and then down here, and then here, and then down here. Right, so we're thinking, okay, how do I get from here to this being my answer? What are some things that you notice? I would love to hear 5 things in the chat. 5 things in the chat. What are some things that you notice? It can be about any part of this problem. Take 1 minute, and when you're ready, you can send me your message. If you've never chatted me before, I would love to see your chat today. If you're one of my people that's routinely just hanging out. Thank you. I've got 2 chats so far. I'm looking for at least 5. I've got 4 chats. I'm looking for 5. I would love 10, but I'm looking for 5. Thank you, Sebastian. Thank you, Marcy. Thank you, Mariano. Thank you, Roxana. I'm looking for one more thing that you notice. Something I noticed is that 4 and 8 are here, and I see 4 and 8, and then 14 and 2, 14 and 2. I noticed that they took this first fraction and they just kind of split it up with that little multiply sign. That's something that I noticed. Something that I noticed. I'm looking for one more thing that I noticed, or that you noticed, or something you wonder. Thank you. Thank you for those chats. Woo, we're up at 6. Yeah, love 6. All right. One thing Sebastian noticed is that it keeps getting minimized. It keeps getting minimized. Yeah, it starts like as something kind of big and it gets a little smaller, 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 right? We're simplifying. That's our goal, is to make it as simple as possible. Someone private messaged me that 4 over 8 gets simplified into 1/2, which is true, right? 4 over 8, 4/8 is the same as 1/2. I love it. Another way that it could be stated is you divide 4/8 by 4 over 4. So divide by 4, you get 1/2. Absolutely. One noticing is that the problems are fractions. Absolutely, right? So we have a fraction here and we have a fraction all the way through, for sure. And then we have a noticing. I noticed in the first part, the numbers were separated from the radicals, right? And then the number fraction gets simplified, right? So here I have a number fraction getting simplified, divided into half. So 14 divided by 2 became the 7, right? And the answer is placed as the numerator, and the denominator is left as the 2. Wow. Wow, that person definitely made a huge noticing here. I think it might help to see some arrows, right? So remember, this 4/8 is turning into the 1/2. The 1/2 is coming down, right? If you imagine the little 1 here and the 2 there, you still see that 1/2 in this problem. And then 14 over 2 becoming 14 over 2, becoming 7. Right? So this is the type of problem. If this doesn't make any sense right now, that is 110 million% okay, because we haven't taught you anything, right? We haven't taught you anything yet. We are going to be working through a problem like this today. Yes, see that. We're going to be working through that problem. So we're going to jump into our notes time today. We're going to jump into our notes. Miss Yama is going to pull her very first small group. Shout out to Miss Yama. Y'all, she's really learning and she's doing an awesome job. So you'll notice today that the notes video is from Miss Yama, which is amazing. So she's doing great. And then she's also going to teach a small group. So I'm going to open up some breakout rooms. Before I do that, right? Before I do that, you might have a breakout room that says Miss Yama. If you have that, that means you answered my email and you wanted to go into Miss Yama's group. She is going to jump in with these humans right here. So if your breakout room says Miss Yama, you should go there, participate, have a great day. If you get a breakout room that says Miss Flores, you're going to stay with me, right? You're going to stay with me and do the notes with me. Right? You're doing those notes with me. I'm very excited. And then you'll have a chance to move into your groups. And if you have one that says Cohort B, right? If you have a breakout room that says Cohort B, that means that you can either go do team video or you can stay with me and do the notes. Okay, so if you have Cohort B, you have the video option, or you have the me option. Okay, let me review that one more time. I'm going to send out the breakout rooms. So let me open these rooms. I'm going to send these rooms. When you hear yours, you can do yours. So if you see Miss Yama, you should take it. If you see Miss Flores, you should ignore it. If you see Cohort B, you should ignore it. Stay with me, do the notes. Okay, so if you see Cohort B, stay with me and do the notes. If you really want to do the video, you can jump off and do the video. All right. So if you see Miss Yama, go there. Miss Flores, you're ignoring it. Cohort B, you're probably ignoring it. I got you, Gabby. Here you go. Okay, my friends. I'm going to switch over my screen so that we can start taking notes. How are we feeling on timing? go ahead and answer that poll for me. How much time do you need to be ready? I know I need about 1 minute to be ready so I can get my share screen going. All right, let's grab that paper and pencil. If you're taking notes online, you can do that. Algebra 2, dividing. All right, if you're already ready, you can go ahead and title your paper. Title your paper, dividing roots and rationalizing the denominator. Dividing roots and rationalizing the denominator. All right. Looks like 13 of us are ready to go. 2 of us need a minute. 1 person needs 2 to 3 minutes. Take that 2 to 3 if you need it. Glad to have you here. Awesome. If you haven't filled out my poll yet, do so now. All right. If you've got the title on your page, go ahead and drop a Y in the chat. Drop a Y in the chat. Thanks, Melanie. Thanks, Roxana. Glad to have you here. Amazing. My chat's blowing up. Love it. So many messages. Remember, as always, if you don't feel comfortable chatting everyone, you can always chat me directly. If you do feel comfortable chatting everyone, that is awesome. Cool. I'm gonna go ahead and end this poll. We're gonna jump in. All right. Okay, so today we are dividing roots, and then we're gonna do something called rationalizing the denominator. Before we start today, I would love to have at least 5 people come off mute today, right? At least 5 people come off mute during this section. So if you feel like you are strong enough and willing to come off mute, I would love to hear that. So please consider that as an option. I think it helps to like get our flow going, but it also can help you to feel more invested in our class. So all of those things are win-wins for me. As usual, if you don't feel comfortable coming off mute or if it's loud, you're always welcome to participate in the chat. I always keep an eye on the chat. It's my #1 go-to option. So let's jump in. Remember that you do not need to write down everything, right? If you are needing to prioritize what to write down because Ms. Mac is writing too fast, always start with the examples, right? The examples. So first I'm going to talk through the steps. So first step, we're going to divide outsides with outsides. This might sound familiar from multiplication, right? We're going to divide outsides with outsides. So I mean these numbers out here, the coefficient, outsides with outsides. And I'm going to divide insides with insides. So I'm going to divide the radicands with each other, right? Outsides with outsides, insides with insides. And then the final step will be to simplify, right? So outsides, outsides, insides, insides. Let's try it, right? So outsides with outsides, 12 divided by 2. Who's got me? 12 divided by 2.
6.
6. Yes, thanks, Roxana. 6 people to come, 6 people to come off mute. That would be great. Thank you, Roxana. I want 6 people. Thank you. So 12 divided by 2 is 6, right? And then I have 160 divided by 5. 160 divided by 5. Thank you for that. Chat is 32. 32. So we did 12 divided by 2 to give me 6. 160 divided by 5 to give me 32. Can you drop a Y in the chat if you're still tracking with me? This is our first question. It's Tuesday morning. Just want to make sure y'all are still out there. Drop a Y in that chat. Oh, I've got 2. Y'all still with me? There we go. More chats blowing up. There we go. Glad to see you this morning. Okay, so we divided outsides with outsides. That is our pink. We divided insides with insides. That is our yellow. And now we're going to simplify the resulting radical. So what we have left over, the result, we're going to simplify this. How could I break down 32? Numbers that multiply to get 32?
4 and 8.
4 and 8. Thank you, Melanie. That is 2 people. 4 and 8. And then breaking down 4.
2 and 2.
2 and 2. Thank you, Gary. And 8.
2 and 4.
2 and 4. Thanks, Roxana. And then we know 4 is 2 and 2. Right? 4 is 2 and 2. Amazing. Just a reminder, if you hold that, if you're in the Zoom window and you hold down the space bar, you can unmute for just a half second. You don't have to press that button. It can be kind of hard to find. So I'm going to cross out the 4, cross out the 8, cross out the 4. Can someone tell me why am I crossing those out?
Because you don't need those numbers anymore. You already used them.
Yeah, for sure. So I don't need them anymore. Already used them up. Definitely. All right. We're looking for groups of how many? What is our imaginary number here?
6.
What was that, Gary?
6.
Oh, good question, or good idea. So 6 is this number out here. It's a coefficient though. We're looking for that little baby number that's right there.
Oh, then wouldn't it be like 2? 2?
Yeah, 2. Good job, Gary. Right. So it's a 2. If it's not written, then it's a 2 there. Right. It's a 2. We're looking for 2 of a kind. 2 of a kind. Do we have 2 of any number? 2 of a kind.
Yes, you do.
Yeah, we do. What number?
2.
2s. Yes, we have 2. So we have 2 there. We have 2 here. And then we also have 2 here. And we have a leftover 2 there. So I'm going to bring down that 6. Right? I'm going to bring down that 6. And then I'm going to bring the 2 and the other 2. And then I have my leftover 2 out here. Leftover 2 out here. For sure. Jennifer and Izzy, glad to have you. Make sure you take attendance, please. We're just starting the notes. This is our first example. So we have 6 times 2. 6 times 2 is 12. 12 times 2, right? We have 12 times 2. 12 times 2 is 24. And we have that square root 2 at the end there. Square root 2 at the end there. So 24 square root 2 is the simplified version of this fraction here, this problem fraction here. So we're dividing outsides with outsides, insides with insides, and we're simplifying. Amazing. All right, we've seen one problem. How are we feeling? How are we feeling after seeing that problem? Got at least 11 people with me here. Appreciate that. Glad to see you. Glad to see you in my poll. Got 14 people answering that poll. All right, got 17 people in that poll, looking for 20. Ooh, 18, almost there, almost to our goal. All right. Let me go ahead and end our poll, share it out. Looking like some people are feeling like 4s, but we also got a fair number of 1s, 2s, and 3s. So I want you to know you are not alone. There are still some 1s, 2s, and 3s. That's great. That means we still have another problem to do, which is awesome. No 5s yet. So we will hope that in our next example, we'll start to feel like some 5s. All right. Let's go ahead and write down this one. Take a moment to write down this one. Thank you to Roxana, Melanie, and Gary, who came off mute in our last question. I'd love to invite 3 more people to come off mute in this next question. 3 other people, though. Don't let Roxanna, Melanie, and Gary do all the work. All right. Remember, our first goal is divide outsides with outsides. Right? Then next, we're going to divide insides with insides. And the last piece is that we're going to simplify. Right? Outsides with outsides, insides with insides. What are our outside numbers? Outside numbers. What are our outside numbers?
36 and 9.
36 and 9. Thank you, Sivas. 36 and 9. What is 36 divided by 9?
4.
4. Thank you, sir. All right, so 36 divided by 9 is 4. Now, what are my inside numbers? Inside numbers.
1,250 and 2.
Absolutely. We have 1,250 divided by 2, right? For sure. Thank you. And yes, Moses, absolutely. If we do 1,250 divided by 2, we're going to get the 625. 625. Please notice this is a fourth root, right? It is a fourth root. So you want to make sure that you write that fourth root there. You might be thinking, do I have to have the same index here? And your answer is that, yeah, you would have to find the same index number. This would have to be the same. If this was a fourth root and that was a square root, we couldn't do it. We'd have to just give up on the problem. We just have to say, there's nothing you can do. Sebastian, absolutely, you're a step ahead of me already. We are gonna have to find 4 groups, right? We're gonna have to find groups of 4, right? So 4 of a kind, 4 of a kind, 4 of a single number. How could I split up 625? That's a big old number. How could I split it up?
By 5.
By 5, yeah, so I can divide by 5. Sebastian, do you know what's left when I divide by 5?
125.
125, perfect. And then I'm thinking, oh, it's divided, it ends in 5 again, so I must be able to divide by 5 again. 5 and what make 125? 25, yeah, Brandon, thank you. Cool, Brandon. And then someone tell me 25 divided is what and what?
5 and 5.
5 and 5, yeah. 5 and 5. What numbers can I cross out of here? What do I not want to distract me?
626, 125, and 25.
Yeah, we can cross out all those numbers. They're not going to bother us. All right, Sebastian told me earlier I need 4 of a kind. Do I have 4 of the same number here?
Yes.
Yes, I do. What is that number?
5.
5, absolutely, Gary. We have 5. We have 4 5s. So we are bringing down the pink 4. And the green 5 is also coming to the outside. Was there anything left inside?
No.
No, nothing's left in there, right? We crossed out this one, we crossed out this one, we used up all the 5. So we don't need to write this, right? We used it all up. So we just have 4 times 5. Oh no, we need one more person. So Roxana, Melanie, Gary, and Sebastian, do not come off mute. Someone come off mute who's not one of those 4 people and tell me what's 4 times 5.
20.
20, yes, Unique helping us reach our goal. 5 people, appreciate you. 20, our answer is 20. Thank you, Joy, also in the chat. All right, snaps all the way around. This was a more challenging problem, but you all made it look easy. Good job. I'm gonna send out this poll. It is okay if you are still a 1, a 2, or a 3. If you're a 0, I wanna hear it too. I just need to know how you are feeling. How are you feeling after seeing these 2 problems? After seeing these 2 problems. All right. Looking good. Got 16 people on my poll. I'm looking for 20. Amazing. Awesome. Glad to see it. Cool. Looking for that last person to vote in that poll. If you're my last human. All right. Here's where we're at. We moved up to threes and fours collectively. A couple people moving into fives, a couple people moving into two. I appreciate this. Looking real solid, right? Looking real solid. So we have these two examples. And this time I got to tell you a little bit of a story. In a time before calculators, I know you're like, what? Why would there be a time before calculators? I know, but actually in a time before calculators, mathematicians decided that having a radical, having one of those square roots on the bottom was a big old problem. Yes, caveman times. Back in caveman times, no calculators. We had to do all the math in our head. Only a very small population of people actually did the math, or like were educated in any way. So back then, they decided that it was very hard to divide by a radical. So let me propose this idea to you. You do not need to write this down. You can do square root of 2 divided by 2 without a calculator, or you could do 2 divided by square root of 2 without a calculator. To put this in perspective, square root of 2 is like 1.414, right? 1.414. So there's more numbers, but let's just pretend 414 for now. Would you rather take this number, 1414, and divide it by 2? Or would you rather take the number 2 and divide it by 1414? Any options? Tell me in the chat. Would you rather do the A problem or the B problem? The B problem? Do you guys know how to do that? Okay, you got 2.0, you're dividing by 1.414. Y'all know how to, you gotta like put a bunch of zeros here like that. That problem looks really hard. Here's a different problem. Let me show you this problem over here. This is 1.414 divided by 2. Oh, yeah. If you thought the 2 would be outside, that's different, right? This would be 2 is the inside number divided by this. That looks complicated. This number right here, right? We could say like, okay, well, it doesn't go into that. So does it go into 14? Yes, it does. 7. And then does it go into 14? So we could do that, right? This one seems much better, right? So what we want is we want the radical to be on the top, because having the radical on the bottom causes a big problem, right? The one on the bottom causes a big problem. So thinking about that, what happened was we decided if there was a problem that had the answer where the square root was in the bottom, then we have to get rid of that square root. We're not allowed to have a square root in the bottom. So turn to your imaginary friend or to your little sister or brother that's standing next to you and say, we cannot have radicals in the bottom. I'm listening. I can hear you all in your houses saying we cannot have radicals in the bottom, right? So if we get to the answer, we cannot have the radicals in the bottom. If we get here, what we have to do is we have to get rid of it. And the way we're going to get rid of it is called rationalizing the denominator. We are taking the radical that's in the denominator. We're going to multiply it on the bottom. And we're also going to multiply it on the top. Right? Multiply it on the bottom, multiply it on the top. What that means is 1 times square root of 3. I'm going to have 1 square root 3 on top. But what's the square root of 3 times the square root of 3? What would this do? Square root of 3 times the square root of 3.
0?
Ooh, good thought. Good thought. It's not though. Sebastian's got it. It would be square root of 9, right? Good thought, Roxana. They're not going to cancel though. The square root of 3 times the square root of 3 would be the square root of 9. But what's the square root of 9?
3.
3, absolutely, Roxana, right? It's just the whole number 3. So the square root of 3 times the square root of 3 is the whole number 3. Just like the square root of 2 times the square root of 2 would be the square root of 4, which just positive 2. You don't have to write these down. Square root of 100 times the square root of 100 is the square root of this many, 10,000, which is 100, right? So the square root of anything times the square root of that same thing is just the number, right? That's what it means. It's the opposite, right? So what they said here is they said, okay, I don't want to have a square root in the bottom. I'm going to multiply times that same square root, and it's going to give me this answer here. So my answer would be square root 3 over 3. And mathematicians everywhere were like, whew, right? Because now they can put their 3 on the outside and the square root of 3, whatever decimal that is, on the inside. That's much easier than the first way, right? Much easier. So when we are simplifying today, if you end up with a radical in the bottom, we're going to multiply times that same radical in order to get to the top. Okay. It's a little wild. It's a little wild. Let's do one more together before I ask you, because I think right now we're like, wait, what? Let's do this one right here. 2 over 3 square root 10. 2 over 3 square root 10. What is the problem? What is the problem? Like, why are mathematicians why are our caveman mathematicians with no calculator? How come they're kind of crabby right now? What do they not like? They don't like to leave their problem like this. What do they not like? Yes, thank you for that chat. The radical that's on the bottom, they don't like that, right? They don't want this radical on the bottom. That's causing a problem for them. So we're going to multiply times that radical on top and on bottom. Right, so we're doing top and bottom. So on the top, that's going to make 2 on the outside and 10 on the inside. So I'm just going to write 2 radical 10. Two radical 10. Cool. On the inside, right? On the inside, or sorry, on the bottom, I have 3 on the outside. And then what did we say? Square root of 10 times square root of 10? That makes square root of 100, but what number does that equal? What's the square root of 100? 10, yes, thank you, Brandon. It's the whole number 10. Okay, it's the whole number 10. So we had the 3 coming through here. We have the square root of 10 times the square root of 10, which really makes the square root of 100, which we know is 10. Square root of 10 times square root of 10 is positive 10. All right. So we have 2 times, or square root of 10 over, what's 3 times 10?
30.
30, yes, thank you. 30. And is there anything we can simplify with the 2 and the 30? Anything we can simplify? Yeah, it can simplify to 15. We can take out 2 from both of them for sure. So we would get 2 divided by 2 would be 1 square root 10. 10 divided by 2 would be 15, like that. We're not going to mess with the inside one because there's not an inside one here. right? So we had outsides with outsides. We can't do insides with insides because there's no other inside here. So this would be our final answer. This would be our final answer. Okay. I think we're still a little scared. I want to do some, let's do a problem together. So draw a line. This is technically the end of our notes. Draw a line on the paper, on your paper right here. Draw a line like that. We're going to do one of the problems from the assignment so that you can see that it's less scary than I am telling you. Right, so we have our notes. Here's our first problem right here. So you should have on your paper, just have a line on your paper. I'm going to put a blank sheet of paper here so that we can block these other problems. All right, and then go ahead and write number 1 here. Write number 1. You're not crossing out anything, you're just drawing a line at the bottom of your notes to signify your notes are done. And we're going to do number 1 together before this class is over. Sweet, so we have 4 square root 3 over square root 15, like that. 4 square root 3 over square root 15. All right, we have outsides with outsides. Outsides with outsides. There's nothing to do there, so we're going to leave our 4 on top. And then we have insides with insides. So I have the square root of 3 over 15. 3 over 15. Can I simplify 3 over 15? Can
Yes.
that be? Yeah, how can I simplify it?
By 3.
By 3. By 3. Right, so I have my 4. And then I would have on the inside, I would have 1 over 5. Here's my thought, y'all. Don't be mad. Don't be mad. This is not my favorite way of doing this problem. Because I think it's gonna get more like I don't like this. But basically this is the same as saying square root of 1 over square root of 5 like this. That's getting complicated, right? But what's the square root of 1? What's the square root of 1?
1.
1, right? So we don't really need to write it. We don't really need to write it. So we really just have here 4 over square root 5. And then why are mathematicians angry? Why are our old caveman mathematicians, what do they not want?
They don't want the radical down.
They don't, yes, absolutely. They don't want the radical on the bottom. So we have radical 5 like that. So
Yes.
on the, thank you. On the top, I would have 4 square root 5 divided by 5. Because remember, square root of 5 times the square root of 5 is positive 5. This is going to be my answer. That's going to be my answer. It seems kind of complicated. I totally get it. If you would like to continue to work with your teams, you are welcome to jump into your breakout rooms at this time. Miss Flores's room is also going to be available. So you can jump into Miss Flores's room to work with Miss Flores. So if you see that breakout room and it has Miss Flores there, you can go ahead and click there. We are having office hours at 10:30. So whenever you don't have Spanish, if you want to come during that middle block, I will do some more problems with you guys. Other than that, you guys are welcome to go. You just have a few problems to complete on this page. Okay. All right. I'll see you all later. Thank you, guys. Bye, team. Jump into that breakout room. Bye, Joy. No, Brandon, like this problem here is just literally like square root 12 over square root 3. I just accidentally started with a very hard problem. Right, so this one is much easier, right? Because you can just do 12 divided by 3 and get 4. And then square root of 4 is 2. Yeah, you're welcome. All right, bye friends. Adios, adios. Thank you, see you later. Hi, Ms. Yamanaka.
Miss Mac, I have a question, a very quick one. So I paused my recording and I left the breakout room. Does it mean that if we end this session, the breakout